Okay, everybody, we're going to look at expanding logarithmic expressions. So we've already done the condensing piece. If you've watched that video, we have the log rules or laws of logs sitting there. And we're going to do some examples today on how to get this to be. Our goal is to get it to be multiple logarithms, but inside, or the argument of each logarithm, is just a single thing without any operations in it that we can get rid of. Now, our argument might have addition or subtraction in it because we know that we don't have any rules for laws of logarithms for addition inside the argument. So we're going to move this. I'm going to move this a little bit. So we're going to look at expanding this one. So instead, we start out with log base b of 6x over y. So you're going to kind of apply these in the rules in the opposite order that we did for condensing. So first, we're going to apply the quotient rule if applicable. So since we have division by y here, we'll say log base b of 6x minus log base b of y. And then after that, we're going to, let me get these things out of the way here. Then after that, we're going to take the 6x. Now this is something a lot of students forget, that 6x, that really means 6 times x. So that can be split up into two different logarithms. So log base b of 6 plus log base b of x minus log base b of y. So if you notice inside the argument, there's no multiplication, there's no division, and there's no exponents. So we want to make sure we keep working until we get to that point. So sometimes we need to use the power rule. The one that we didn't use in that case is the power rule. So we end up with something like log of a base b of a over c. Now what I like thinking this is kind of what I do. A over c is the same as a times c to the negative first. So having over c, that really means c to the negative first there. So that means we can now have a product rule, log base b of a plus log base b of c to the negative first, and now the negative one can drop in front. So I think you can eliminate the quotient rule if you know your exponent rules and can handle those negative exponents easily. Either way works, it's fine. All right, so now we're going to work on this one, natural log of x to the fourth y over 7. So in this case, the very first step here is we're going to take, if you're it's easy to miss the natural log right there. Okay, so this is going to be natural log of x to the fourth y minus natural log of 7. So there's the quotient rule. Now I have a product in here. So natural log of x to the fourth plus natural log of y minus natural log of 7. Now I have an exponent. So I'm going to say 4 natural log of x plus natural log of y minus natural log of 7. So I'm taking the natural log of x, natural log of y, and the natural log of 7. And for the natural log of x, after I take the natural log of x, I'm going to multiply it by 4. So I'm going to move a little bit further down. Let me show you real quick how you would do it with negative exponents. So you would first say, that's just the natural log of x to the fourth y times 7 to the negative first. So now what you'd say is that's going to be 4 natural log of x, because I'd split off the x, the natural log of x to the fourth, and drop the 4 in front, plus natural log of y, plus negative 1 natural log of 7. And so we can have this over here can be 4 natural log of x plus natural log of y minus natural log of 7. All right, let's move on to the next. These problems will kind of get a little bit more difficult as we go along. If you want to pause the video right now, you can try that one. All right, now that you're back, I'll show the solution. Sure, we'll go on. Yeah. Let's go back to safety. I guess I'll have to, I'm in the wrong spot. Let me get back to where I was. Maybe? Nope. Okay, I got to get back to that website. Sorry. Here's where I've been getting my examples from. There we go. It was all in LaTeX at first. Okay, number 6. So on this one, if you've been working diligently, and then I had to do this. So you're back, and so this one's going to be log of 2 log of x plus 3 log y minus 4 log z. That's what that's going to be when it's all said and done. All right, so you're going to practice those, and eventually you'll be able to do those as fast as I can. They're not, once you remember the rules, it's not too bad, and it really gets a good idea for some exponent rules. Okay, here's a piece, log of square root of x. You do have to take that and say that's the 1/2 power, because that we are responsible for removing all exponents from the argument. So square root is the 1/2 power, so that's going to be 1/2 log x. So this is cube root, so that's going to be 1/3. So there's a couple ways you can do this one. So we could have natural log, and you can say this is x squared to the 1/3. And now this whole thing's in the natural log. And now you can do power to a power rule if you want. So this is natural log of x to the 2/3. And you can say, oh, it's got an exponent, 2/3 natural log of x. Or somebody else might have done and said, well, I'm going to say at this step, I'm going to take that, at this step, I'm going to take the 1/3, drop that in front, 1/3 natural log of x squared. And then, oh, that's still got another exponent, 1/3 natural log, 1/3 natural log of x with the 2 multiplied in. So 2 times 1/3 is 2/3 natural log of x. Either way it works. Doesn't matter which way you do that one. Now let's look at the next one. Come on. So can we expand natural log of x squared plus y squared? Can I get these 2's? They both got 2's. Can I drop that 2 in front? The answer is no, because it's addition right here. There's no way to expand a logarithm if you've got a sum or a difference sitting in there. All right, something that's a little bit more difficult. So I'll slide down. All right, so what I would do on this one, and what I think, well, if you're somebody that does a lot of, that does the quotient rule, you would have log base 6 of 64 x cubed times 4x plus 1 minus log base 6 of 2x minus 1. Then on this one, you'd have log base 6, log base 6 of 64, because that's one of the multipliers in this chain. So is x cubed, so plus 3 log base 6 of x plus log base 6 of 4x plus 1 minus log base 6 of 2x minus 1. So that's all using the product rule, the quotient rule, and the exponent, or the power rule in that situation. So this 3, I did this in one step here. I knew that I was going to split that as natural log, or log base 6, of x cubed, and that 3 was going to drop in front. All right. Let me get to the next piece. Let me get back to this. And I got 2 warring applets here. All right. So now looking at this one, go ahead and try it. Pause the video if you're back now from the pause. Now we look at this and we have the quotient. The whole argument has a quotient. So I'm going to say this is natural log of the square root of x minus 1 times 2x plus 1 squared minus natural log of x squared minus 9. Now, what are they baiting you on here? Is this the same as x minus 3 squared? No, it's not. We can't factor that squaring out of there. It is the difference of perfect squares, so we could factor it and get some more logarithms, but I don't think we need to. This guy right here is going to be the 1/2 power. So I'm going to pull that off as the 1/2 power. It's affecting the entire argument of that natural log. So I'm going to say that's 1/2 times the natural log of x minus 1, 2x plus 1 squared. So that's my argument there, minus natural log of x squared minus 9. And now I'm going to split this product into two different logarithms. So when I use that 1/2, I'm going to have 1/2, and that has to hit both the logarithms. So I'm going to put parentheses. So I'm taking out one thing and replacing it with 2. So parentheses are a good idea there. So natural log of x minus 1, and I'm going to say plus 2 natural log of 2x plus 1. There's my big parentheses, and then I have to make sure I carry this along, x squared minus 9, there. Now I can put that 1/2 in. So my final answer is 1/2 natural log of x plus 1 natural log of 2x plus 1 minus natural log of x squared minus 9. And I guess what I should say is that sticklers might say, well, this is really x plus 3, x minus 3. So what you really should have at the bottom here is natural log of x plus 3 minus natural log of x minus 3. And again, that's kind of the same thing there. This is a product, so it got replaced with parentheses, and that negative got distributed in. So you can kind of think about that, how that works. But if you didn't get the x squared minus 9 broken apart, I think that would be just fine. All right, that's expanding natural logs or any kind of logarithms using our expansion rules. Hope that helped. We'll see you in the next video.